Hello friends, welcome to History Doc. I'm Luna Fa. Before you get lost in this video, make sure to hit the subscribe button.
Hey everyone, and welcome to The Explainer. You know, for well over a century, the sinking of the Titanic has completely captivated our collective imagination. But the popular narrative, it usually boils down to just one dramatic stroke of bad luck, an invisible iceberg in the dead of night. Well, today we're gonna look past those Hollywood myths and conduct a real forensic investigation. Because as you'll see, this disaster wasn't just a sudden freak accident. It was actually a complex, cascading series of both engineering and human failures. By digging into the blueprints, the materials, and the historical records, we're going to uncover exactly how a literal marvel of modern engineering became the ultimate tragic lesson in hubris. Okay, let's take a quick look at our roadmap. We're going to cover 1. Anatomy of the illusion, 2. The structural flaws, 3. Shattering steel and rivets, 4. The ship that watched, and finally, 5. Engineering a safer future. Let's dive right in. Water with 11 massive decks, all divided by 15 watertight bulkheads. The Titanic was, quite literally, a floating city. It was designed to hold up to 3,500 people, that's passengers and crew, combined, and honestly, its sheer unprecedented size was supposed to be its ultimate defense against the harsh elements of the open ocean. But to really ground that massive scale and everyday luxury, let's look at the number 4. Picture this, first-class passengers strolling along the beautiful A-deck promenade, which, by the way, was half enclosed just to protect them from the sea spray. They could visit the purser's office and rent their very own numbered teak deck chair for just 4 shillings. That is exactly $1. And for that price, stewards would literally bring them hot broth or tea while they took in the sea air. It really paints a vivid picture of a ship built entirely around comfort and opulence, where this absolute illusion of total safety was just woven seamlessly into everyday life. All right, moving on to Section 2, the structural flaws. If we examine the ship's cross-section here, you can clearly spot the layout of those 15 bulkheads I just mentioned. But if you look a little closer at the structural design, you're gonna see their fatal flaw. These so-called watertight walls, they only extended a few feet above the waterline. They didn't go all the way up to the upper decks to actually seal off the compartments. So what does that mean? Well, when the ship scraped that iceberg and the water flooded the forward sections, the bow naturally dipped. And as it sank lower, the water simply spilled right over the top of one bulkhead and poured into the next one. It's kind of like an ice cube tray overflowing. It effectively pulled the ship down under its own cascading weight. To really grasp just how severe of an oversight this was, let's contrast the Titanic's flawed transverse bulkhead design with a naval standard ship from that same era, the Mauretania. Now, the Mauretania used longitudinal coal bunkers. What that means is, if her outer skin ruptured, the incoming water would hit packed coal and be tightly confined to small, specific bunker compartments. It would have safely checked the inflow and kept the ship from listing or sinking. The Titanic, on the other hand, let that water spill freely across massive compartments that spanned the entire width of the ship. And this brings us to the absolutely heartbreaking what-if of the lifeboats. Just look at the stark contrast between the planned and actual capacity. Originally, the deck plan showed accommodations for 56 lifeboats. That would hold roughly 3,100 passengers, which is enough for almost everyone on board. But on the actual maiden voyage, the Titanic carried a mere 20 lifeboats. That's only enough space for about 1,000 people. They made a conscious choice to prioritize open deck space and aesthetics over, a realistic worst-case scenario backup plan. Which leads us directly into Section 3, shattering steel and rivets. Let's zoom our mental camera all the way down to the molecular level. We really need to talk about a phenomenon called the ductile to brittle transition. Generally speaking, metals are ductile. They absorb energy and bend or undergo plastic deformation before they actually break. But the builders of the Titanic might not have fully accounted for what severe temperature drops do to their materials. When the Titanic hit the freezing 0 degrees Celsius waters of the North Atlantic, the steel literally underwent this transition. It completely lost its flexibility, became incredibly fragile, and meant it would snap under much, much lighter loads. We know this for sure because of modern engineering lab tests. Take the Charpy impact test, which is something engineering students do in university courses like ME 330. In these labs, they test materials ranging from 1045 steel and 2024 aluminum, all the way to HDPE, which is literally grocery bag plastic, and PMMA, a glass alternative. I know, it might sound kind of crazy to smash everyday grocery bag plastic to understand a 1912 shipwreck, but using a heavy swinging pendulum to strike these specimens at different temperatures proves a universal truth. Materials that shear and bend beautifully at room temperature will shatter flatly and cleanly at freezing ones. And that right there is exactly what happened to the Titanic. Samples recovered from the wreck show this incredibly sharp, clean failure surface. Because of that transition, the freezing water caused the ship's steel hull to fail. And worse, the rivets holding those steel plates together sheared and popped off like brittle glass instead of bending with the impact. So the iceberg didn't just cut a clean hole. The impact caused the frozen, brittle seams of the ship to literally burst wide open.
All right, Section 4, the ship that watched. Let's pivot over to the human element.
Knowing what we know now, that the ship is rapidly taking on water, the bulkheads are completely failing, and lifeboats are drastically scarce, we have to ask the most painful question of the night. Was there any chance for a rescue from a neighboring vessel?
Well, in one of the absolute darkest historical footnotes of this entire event, the answer is yes. The British steamship SS Californian was sitting right there, close enough to the Titanic to clearly see the distress rockets firing off into the night sky. Yet, inexplicably, its 55-person crew took absolutely zero action to assist the sinking giant. A rescue operation from the Californian could have fundamentally changed the death toll of this disaster, but instead, they remained the ship that simply watched. Finally, Section 5, engineering a safer future. Let's look at the aftermath and what we took away from this.
As you might expect, the sinking of the Titanic directly mandated massive, sweeping changes across the entire maritime industry. Almost overnight, shipbuilders were forced to extend those bulkhead heights all the way up to the upper decks, making the compartments truly watertight to stop that fatal spillover effect. Plus, ships that already had double bottoms were retrofitted with a double layer of protection that extended all the way up the hull.
To wrap up our explainer today, I want to leave you with this thought. As engineers and designers, we are always learning and always improving, and this case is no exception. It really forces us to ask a profound question, right? How much of our modern safety, our building codes, and our structural engineering today is still built directly upon the wreckage and the lessons of our greatest historical failures? The Titanic wasn't just a horrific tragedy, it was the harsh, unforgiving classroom that taught us how to build a safer world. Thanks so much for joining me on this deep dive, and remember to keep questioning the structures around you.
If you liked this video, give it a thumbs up, share it, comment below, and don't forget to subscribe.